he got on the agenda. We never actually took him off, but he's here, so that's fantastic. Yep. Thanks for being here, Chris.
Yep.
And I'll let you take it away, man.
All right. All right. Yeah, I actually have been down here for a week with my family, so we did the Disney World thing and all that kind of stuff. But putting the presentation together on the road, so there's not really a whole lot of fancy pictures. I have a little stick figure animation, so bear with me. And this presentation's changed several times. I've got 4 colleagues here from Alcoa, and one of the things we talked about when we started discussing this conference was how are we going to, of course they wanted to come, Clearwater Beach, who wouldn't? So we said, okay, we'll plan this, but let's look for ways to use the equipment that's not traditional. So, bring me something that we can come and talk about and share at a users conference. I've got several of those to share with you today, but mainly, this has been 6 years in the making, that we've been using ultrasound, and we're going to talk about getting your program over the hump. A little fine print here. I'm not an expert in ultrasound, so I'm really here to just share with you again what we're doing. We're here to look at what you guys are doing as well and, see how we can improve our process. And pretty much, throughout the group, you guys are either here because you don't have an ultrasound program maybe you're here, you want to implement one. Perhaps you're here and you have a program that's just not getting the results that you expected. Maybe you're here for just benchmarking best practices. You want to expand your program, look at how to interface your ultrasound program with other condition monitoring technologies. Pretty much, I think Senator Campbell said it best. I like the quote where he said that we're not as good as we should be, or we can be, or that we ever will be, because it's pretty much a journey with any one of these technologies. As you implement it, it's not something that you're going to get done overnight, and it's something that you can always look for opportunities on how to improve. All right, the idea here is that we've talked about this PF curve, and we've looked at it a couple of times. The PF curve, the far left, you've got proactive zone. You've got a piece of equipment that's doing what it should be, doing what it's designed to do, and then it's going to run for some period. It's going to start to break down, and as it does, it's going to start displaying symptoms. And you can use any one of these technologies to, along that path, to identify these symptoms, recognize that a fault or failure is pending, and start planning for your corrective action. Ultimately, what I want to stress is that, each one of these technologies has strengths and weaknesses in identifying various different failure modes for different components. Ideally, as you start implementing any one of these technologies, what you'll find is the data that you'll get is going to start showing you that the failure modes or the failures that you're seeing were introduced by ourselves. So it was basically our work practices, how we operate the equipment, how we assemble it, how we maintain it, our lubrication practices, we talked about that. Pretty much on the proactive side, how do we prevent it from happening in the first place? Because it's really cool that we can take a technology and see that we have a problem, but ideally, we don't want the problem to exist in the first place. We want to get the maximum life out of our equipment. So, that's something that we're really stressing. I guess you guys are a little familiar with Alcoa. Senator Campbell talked about the smelting side. We're on the refining side, but pretty much we're all pursuing reliability excellence. And I think everyone in this room, to some extent, is on that same journey. So we'll talk about how all of these connect to ultrasound and a condition-based strategy. All right, so we're talking about how to get over a hump. What constitutes the hump is with any one of these technologies or are just strategies. You know, when you say, hey, I want to get from point A to point B, there's going to be barriers, obstacles. You basically got a hump. And so I just put together, you know, these group of people trying to pull a factory over the hump. You've got to have goals. You got to define what your objective is, because you got to get a budget. You got to buy equipment. You're going to have resources. You got to get buy-in. Training is required. Experience. I mean, you can't just do training and expect the guys to just run out. I'm trained, I'm qualified, I'm certified. Bam, I'm doing this. There's some level of experience that's going to be required. Awareness training for the rest of the people in your plant. They need to understand what the processes are that you're trying to put into place, and they got to buy into that. So to really be successful, you got to have this buy-in, and you got to complete the repairs. I mean, one of the things you're going to find with any one of these technologies, you go out, you do an air leak survey, you got a backlog of work. What are you going to do with it? Because now you got a maintenance organization that's sitting there saying, we're already slammed. How are we going to implement this? How are we going to prioritize? So that's all part of your hump. So how do we get over that hump? And there's really no sound, but yeah, this guy's trying to get over the hump.
Wow.
He doesn't quite make it, so. All right, so he's going to go down, he's going to try it again. And that's the tendency that we have, is that we just want to take what we have, take this new program, and we're going to charge the hill. Everybody wants to be that soldier that charges the hill and wins the hill. And that's our first tendency. So the main thing with that, I mean, there's times where you guys are going to charge the hill, you're going to even have a plan, and you're not going to make it. Come back down, regroup, learn from it, and charge the hill again. Like I said, you know, we've been doing this for 6 years with ultrasound. This is where we're at today. Our current program, we've got 21 technicians that we've trained and certified. 11 of those are level 2 certified, and each one of these guys are practitioners. I mean, I'm really proud of our accomplishments with training. We've really been focusing on implementing this program and getting giving the people the resources and the tools necessary to do their job. So, you know, we've got, again, I've got several colleagues here that represent a portion of this group. Powerhouse supervisors. I mean, these guys, from an energy audit standpoint, we've got a supervisor and a powerhouse operator here, and they're fundamental. I mean, they're the ones making the steam, making the compressed air for us. So it starts with them, and having a good sound ultrasound program in those houses is where it starts. And we've got machinery lubrication technicians. We've got 8 of them for our plant, and they're all trained level 1. They're out there, they're using ultrasound for ultrasonic assisted greasing. And then we've got our condition monitoring team, which is made up of 4 operators, and those guys do a lot with ultrasonics. And then we've got 6 mechanical technicians that use ultrasonics for various means we'll discuss. And then we have 1 guy that's actually using ultrasonics and introducing that to his electrical inspections. They're doing infrared and motor current testing now, but they're implementing ultrasound as part of that inspection process. And we've got 14 instruments. We started out with our UltraProbe 550. We've added 4 9000s. We've got a 15,000, and we've got 8 loop caddies. And really the main thing that we want to talk about is the applications, because you've got traditional means, you know, that we've all talked about: air and steam, ultrasonic greasing, using ultrasound to trend decibel levels, using ultrasound for slow speed analysis. You know, from a vibration background, there's some things that you just don't monitor with vibrations. Moving too slow, ultrasound's an excellent tool for that. Diagnostics, we've used ultrasound many times to go out and probe equipment. It's just giving you that extra sensory ability to hear what's going on and to pinpoint what's happening in a machine. Again, electrical surveys, power distribution lines, really scanning using ultrasound for safety perspective before we open up MCC starter cabinets, listening for arcing, tracking. Some of the unique things that we're doing, vacuum pumps. We're using ultrasound to identify problems with our vacuum pump systems. But I don't know, how many of you guys have heat exchangers, tubular heat exchangers? All right, so our tubular heat exchanger, we're basically sending steam in, passing products through the tubes, and you've got this vessel that you want as much surface area of those tubes to be exposed so that you get good heat transfer. Well, as soon as that heat hits the tubes, it condenses. Now I have to move that water out. I've got a pumping system that's removing the condensate. In our particular application, we're pulling processed steam, recycling it, and so we have a system that's under a vacuum. And what we found is any pumping system that's under a vacuum, if the packing starts to fail or the seal starts to fail, it's actually pulling air in. It's not leaking product out. So you don't see it until your efficiency is corrupted. So with ultrasound, we can actually hear that, make packing adjustments, and maintain peak operating efficiency. We use it for conveyor inspections, air slide conveyors. That's something, I don't know if anybody has air slides. Yeah, that's like a fluid bed. We actually have a media, maybe a cloth media or a rock, and we pump air in the bottom. It's on a slope, so it allows us to gravity feed. So we're able to use that, dust collectors, and of course baseline inspections. All right. Let's see. We've got talk about our journey with ultrasound. We actually started, I said 6 years ago, but back it up 3 more years to 2003, and that's when we bought our first UE 550. And it was one of those things to where we realized that compressed air was valuable. And so based on that, we said, hey, we got to go do something. We went and bought a UE 550. We had a summer intern. Said, here you go out and find air leaks. And he did okay, identifying some air leaks, but the main thing was we didn't get a lot of focus from UE or from our ultrasound, but our biggest benefit at that point was just awareness that, hey, compressed air is expensive. I mean, we had guys using air horns to, or just compressed air to cool themselves down. We replaced that with mechanical means, fans, stuff like that. In 2005, we went to a conference and wasn't really focusing on ultrasound, but in that conference we were talking about ultrasonic greasing, predictive maintenance. We said, you know what, we've got one of these tools sitting on the shelf, makes a good doorstop. We haven't really used it in a while, but we said, let's go back and do something with it. So we came back, and in 2006, I was nominated to go do a steam survey. And ultrasound works well for identifying whether a steam trap is good or bad. I think we're going to get into some of that tomorrow, workshop. And you can actually hear, is it cycling, is it not cycling? We found that we had a lot of traps that just weren't cycling. One of the things, if you have a leak or something that's stuck open, you can easily put a dollar figure to, I'm losing steam. What happens when it's closed? You guys thought about that or run into that? If you got a steam trap that's not working, how do you put a dollar figure on that? Especially when you got the majority of your failed traps are not working. So we'll come back to that, but 2007 I did another audit, and I found that it didn't look like much was done. I mean, we went through the efforts of tagging, putting stuff in our maintenance system, and just really not a lot of activity. So, challenges with a steam trap program. What I found was that we basically lacked standardization. For years, we had consultants or trap manufacturers that would knock on your door and say, hey guys, we'll come in and we're going to do this audit for you, and we'll tell you what's wrong, and we'll sell you a whole bunch of traps. And so we had a big variety of traps. We would install a lot of them, and we found that there's a lot of variety in how we done that. We had disc traps, thermostatic traps, bucket traps. I mean, you name it, we had a mixture of all of it. And what I guess what I want to stress here is that you really need to understand your steam system. That's something I didn't have the benefit of. I just went out and learned by doing. But what we found is that we had a lot of insulated or insulation issues. And one of our main problems was we had a lot of scaled accumulators, your little pocket that would capture the condensate and feed it to the trap, allow the trap to discharge the condensate. It's easy to go by and say, yep, that trap's not working, and go out and put another trap in its place. And well, guess what? The system itself was broken, so your new trap that you just put in place is still not working. The previous trap was probably not broken. So we ran into a lot of that. We had to go and clean our system up, and we had to develop a standard. And that's going to be really important. You got to understand what good looks like, not only from what you're inspecting, is it cycling or not. What does a good steam trap system look like? And I tried to just sketch a little scale of what a basic trap system would look like. But you're going to run into master trapping. You're going to, I think someone said earlier in the conference, you may see traps that are installed backwards. You know, they got an arrow on them, but you know, humans, you know, we're going to mess stuff up. You're going to find stuff that's backwards. It might be insulated over a trap that may not stop the performance, but it will hinder it. And then process trap issues. I mean, where are you going with the discharge of that trap? Are you tying into move condensate with a steam pump? You know, if that steam pump's not working, your whole system gets constipated and backs up. So just be aware of that. All right, so continuing on with our journey in 2007, we had fixed our steam issues and everything was running great. So we said, let's go back and reintroduce our air leaks survey. And so we took our largest consumer of air in the plant, and we took an operator and said, hey, congratulations, you're now the air leak auditor. We gave them the 550 and sent them to work. And one of the things you're going to find out about air leaks, if you took a room this size and had a spaghetti bowl of air lines running through here, there's going to be air leaks everywhere. Now multiply that by 100, and you can find yourself, you may intend to just walk a pathway and say, okay, I'm going to go here, I'm going to come back that way, and what you're going to find is you're going to be chasing rabbits all over the place. And so we'll get into that. One of the things we did was try to limit it down into 2-hour blocks because we didn't want to spend all day just chasing rabbits around the plant, and we wanted to be as effective as possible. But in 2008, we focused on really making our air and steam trap systems evergreen. And so we brought in 2 more technicians, and we added one ultrasound UltraProbe 9000. So now we had 2 instruments, a 550 and a 9000, and we had 3 guys. So I had the bright idea that we would schedule the instrument use. You know, you're not going to be using these every day, we'll just share them. Guess what? Everybody wanted the 9 and not the 550. And so there was all kinds of issues with trying to make that work. But the main challenges with an air leak program is it's hard to stay on path. That's what we found. Routes were inefficient because we spent a lot of time off path. And so what we did, I'll go ahead and hop over one. That just represents, I was talking about a small route. That may be a system of tanks with air piping going through it. And you may have a tendency to try to just draw a line. I'm going to go straight. I'm going to come back down. I'm going to kind of weave through. What we found that worked was actually color coding and saying, you know what, I'm going to stay in this boundary. I might divide this room into 4 or 5 equal sections, and today I'm going to take it, and I'm just going to go out, and I'm not going to spend all day. I'm going to spend about an hour, find some air leaks, tag them, and then I can be more efficient and effective doing that. Come back, enter those into our maintenance work system, and then come back, tomorrow, next week, whenever. Take small bites, and people will want to do it. I mean, they don't necessarily just want to go meandering through equipment all day long, so breaking it down was effective for us. Training. That was another thing. I went back in 2005, sat through a level 1 training class, came back, said, man, this is something that's really good, really easy to do. Didn't realize how much I really learned about ultrasound in that week. I thought, well, I can just pass it on. And so we made that attempt. Just opted for hands-on instruction. Hey guys, here's an ultrasound, use shielding, so forth, so on. And what I found down the road is that we missed opportunities. I think with that training, there's a reason for a 3-4 day training, is because you get to hear all the different aspects of ultrasound. You start clicking and understanding what it is about ultrasound that is effective, and it'll open up doors of opportunity for how to use it elsewhere. Scheduling work is another big challenge. Again, part of that hill is you identify a whole lot of work. How are you going to fix the problems? So originally what we did is we took a clipboard, wrote down and tagged everything, took pictures, identified it, numbered it, and then we created one work order in the system. The guys would go out and they would repair 2 or 3 of them, complete the work order. And so generally what happens when you do an ultrasound inspection, if you go out and it's something you can fix, you want to fix it right there, right? Don't just leave it, get the instant bang for your buck. Take a wrench with you, tighten something up, whatever it takes to eliminate the problem. Now, if you can't, what are some reasons why you can't fix a problem out in the field? Maybe you have to isolate the system. Maybe it's a hole. It needs to be planned and scheduled, and each individual one that you couldn't fix in the field needs to have some measure of planning associated with the repair. So what we found that works best is to generate an actual work request in our maintenance system for each individual leak. I mean, we may charge it to the one asset that is air system for this department, but then that way you can track the repairs, planners can plan the repairs and schedule them, and it becomes more effective. All right, we'll skip through that. All right, 2008. By this time, we were doing vibration, infrared, some motor current testing, ultrasound. So we had a lot of data coming in that was telling us, hey guys, you got problems. We were able to Pareto that and say, what is our leading failure modes? And we found that it wasn't misalignment or imbalance or looseness. It was our lubrication practices. So we said, okay, this is good to know. And we started looking at what is the best way to improve our process. So we started down the path of lubrication excellence. We went and we did an engineering study. We calculated a loop strategy for every asset, every loop point. 3,492 loop points. So everything has a strategy, an amount, and a frequency for maintaining it. In 2009, we said ultrasonic greasing is something we hear a lot about. Let's try it out. So we bought a grease caddy and trialed it. Worked great. Loop techs enjoyed it and was able to improve their process. So we expanded the program in 2010. We trained all of our lubrication technicians in ultrasound and lubrication technologies, and we bought 8 additional units, and now that's what we do for greasing. 2010, we went ahead and added how many? We had three additional UltraProbe 9000. So that gave us 4. We added 1 more operator doing general inspections. And at this point, we added handheld computers. And by adding that, now we can trend. And Ultra Trend, you have software that does that. One of the things that we do, we trend temperature, decibel levels. The guys are able to see it in the field if it alarms, percentage of change from baseline. What we hope to do with that is eventually move to a full-blown condition-based greasing strategy. So we're still using our engineering study information where we know the frequencies and the quantities, but we're using ultrasound when we go out on a 6-month re-grease route or 90-day, whatever it is. And when we add that 0.5 ounces of grease, we don't just add 0.5, we adjust it based on the ultrasound. So another thing that we're doing is starting to trend crest factor. Is anybody familiar with crest factor? Vibration guys out there? Okay. That one of the things about crest factor is you can actually look at a waveform. So you got these squiggly lines, right, that's representing the sound or the vibration of this equipment. The difference between that energy, the RMS value of that energy displayed in that waveform, and the peaks, the highest peak, is your crest factor. So it may be 5, 4, 3. As it starts to trend up, spikiness basically tells you I've got impacting. So maybe I got a bearing going bad, a gear going bad, whatever. So we're trending that. 2011, we bought us a UP 15,000 in a parabolic dish. and we started in on the electrical side of this and really using, adding ultrasound to our infrared program, motor current testing, and we're just getting started with that. So not too much to talk about there, but it's pretty exciting to see how that's going to turn out. And just to summarize here, we've got the main things that we've learned along the way is that you got to invest in your people. Your people are your most important assets. I can have a whole lot of instruments and a lot of people that don't know what they do or how to use them. So training, continuous development for those people, cross-training so they understand other technologies and how all those connect. That's been important to us. Align your goals with your organizational goals. So take time to find out what's important to your boss, what's important to the management staff. And again, we talked about that. Managers look at what? They want to know the money. So how does ultrasound fit into the money? I mean, you can talk about energy costs, but it needs to be some kind of direct measurement. Energy, gigajoules per ton, understanding parts inventory, turnover rates, get into lubrication, and you're going to talk about barrel consumption, grease consumption, spare parts, bearings. Break it down. What really works well is because everybody wants a piece that's easy to say, oh, we're going to reduce R&M maintenance budget by 10% by doing all of this. Well, guess what? There's 15 other people with different projects doing the same exact thing, claiming a portion of that money. Find something that is related to the field that you're talking about. Maybe it's a particular asset. We're going to use ultrasound to identify bearing defects on this type of pump or this type of motor. There's been some really good examples presented. That's the kind of stuff you want to tie into. Something you can measure, small measurable improvements that you can impact the bottom line with. Keep it simple. Use the simplest technology, the most cost-effective means to improve the reliability. And I have a tendency myself to want to complicate things, and I've got people on my team that help steer me in a direction. It's easy to want to go up and take vibration and identify how this thing is moving, and that's an interrace bearing fault and this is going on. Well, which one of the gears is bad? At the end of the day, what matters, we're doing condition monitoring, right? So if you're monitoring the condition of something, you care to whether it's binary, good or bad. That's where you start with. And if it's bad, you may want to dig into it and say, okay, I want to know that it's this particular type of problem because that's going to lead you in a direction of how do I prevent it from happening again. But keep it simple. I know there's been times where we go out and we're looking at a piece of equipment and my partner's over here feeling all over the place and looking for water that's maybe beating up on something, and I'm way off here trying to use the instruments. He's like, oh yeah, we already figured this out. It's over here. Look at the water. It's moving. So always keep it simple. Look for a simple approach. And there's 4 rules that we use for anything that we implement. And basically, at an activity level, a task level, you want to ensure that the activities are clearly defined and they're repeatable. So you've got 4 technicians out there doing a process. Number 1, I want to know what the content is. What is the inspection? I'm coming up to inspect this pump. I want to know the sequence of the inspection. That's where the handhelds come in place, or a checklist. Saying check 1, 2, 3, 4. Everybody's doing the same thing. And if someone says, hey, I'd like to do it this way, evaluate that, make that part of the process. So keep it repeatable. It should take me so much time to inspect this piece of equipment. If it should take 5 minutes and it takes me 8, 9, 10 minutes, I got a problem. Something stopped me from doing my job effectively. So you need to have a specific outcome. It needs to be timed and it needs to be repeatable. Again, next step is your customer relations. So how does this activity relate to customer, supplier, my connections with the service that I'm providing to someone else? Communications need to be binary. It was either good or bad. It needs to be paced. Pathways need to be simple, not convoluted. You don't want to be going from here to there to there. Try to keep it straight as possible. And your outcomes need to be measured. and basically make it to where your problems are easy to identify. And that way, as you start to charge that hill, you start to see early on what you're running into, where are the barriers at, and then at the lowest level possible, if they're expecting a certain outcome, the technician can step in and solve his problems most of the time at that level. So that's just our recommendation. So I think that's the conclusion. I want to open it up for questions, comments.
Sorry, I noticed that in your first slide you mentioned something about dust bag.
Dust bags.
Yeah, what do you do?
Yeah, actually, the dust collectors. That's something that someone mentioned, I guess, yesterday, talking about dust collector VFDs. And that's actually something I threw in here right before we started, because guys were like, hey, man, that's ideal. I don't really have a lot of data. We've looked for leaks on dust collectors. But really, he was saying, hey, why couldn't we use ultrasound to listen and trend what's going on in the dust bag? Is it, you would imagine that if it starts to get plugged, it's almost like putting your hand over a vacuum cleaner. You can get that, That's what we're expecting. But that's the kind of ideas, when you come to a conference like this, we just threw that one in there. So that's not something I have a whole lot of data on, but we're going to chase that one down. All right.
Chris, I've asked several people here that, we've always see the savings that we've made. How much of it, and other people too can come to me, how much have you been able to reinvest the monies that you saved at Alcoa? Back into what you're doing,
back into
equipment, machinery, processes.
All right, so the question is, how much of the money have we been able to reinvest into other technologies or processes as we implement?
Saved, because I know where
Right.
I've had a lot of issues where we've saved, $100,000 and say, okay, let us invest it, let us improve what we have.
Right.
And they cut it from your budget.
Yeah. That's, I guess, when you start looking at maintenance budgets, I mean, you're already starting behind the ball here, because you've got your corporate saying, hey guys, let's cut maintenance budget by 10%. So what's the first thing you do? You start cutting planned maintenance. So as you start, there's a hurdle that we have to get over, and that's, if you start saving money, basically you're enabling yourself to do other scheduled maintenance. So how does the money ever hit the bottom line? And that's part of when you start claiming cost savings, and somebody eventually says, hey, I want my check. I just saved X amount of dollars, and they want to, okay, well, good job, guys, cut it another 10%. What you're going to find is with your maintenance practices, I think, first of all, you're going to get to do more planned maintenance that you would have normally had to defer. So in doing that, you all see the math here. It's just going to, he saved $500,000. Well, I just spent $500,000 doing something that I wasn't going to do. And I think eventually you start to impact the maintenance budget enough to where it does become a trend downward. I think that's one of the reasons that we start small and we say, okay, instead of looking at the maintenance budget as a whole, because when you really don't see a lot of movement up front, if you can measure part consumption. I mean, one of the things, we were able to cut our lubrication consumption by half, bearing consumption by half, gearbox maintenance and repair, making reductions there. If you have a maintenance system, that enables you to mine data out that's specific to an asset type. So find out where you're spending a lot of money. What is the failure mode that you're dealing with, or modes, and then how am I going to address that with these technologies? And my goal may be through the implementation of ultrasound and vibration and good lube practices, good alignment, precision maintenance and assembly, that now I have a defined strategy that addresses the failure modes of this type of gearbox that maybe I'm spending $1 million a year on. So try to find situations like that, because that's something that you can actually go to management and say, look guys, historically we spent $1 million over the last couple of years. Guess what? Now that we're doing all of this right, Last year we only spent $500,000. You know, maybe we're trending down and even doing better. Next year we spent $250,000. So by doing that, you know, I'm not guaranteeing you that the money didn't get spent elsewhere, but at least you can show improvements in your process and you can start gaining momentum to address other problems. And ultimately, I think you will impact the maintenance bottom line. So, all right.